Hello, welcome to another Sema tutorial. I'm Francisco, and in this tutorial series we're going to talk about the language design workflow in Sema. Now, one of the key principles of the Sema project is to empower creative people, and in particular, live coders, to design their own live coding languages. But why is this important? Why should I care, you may ask? Now, as you may know, every design artifact ingrains and carries the assumptions of the designer, the knowledge, the context, the background, sometimes the designer needs. And live coding languages are not an exception to this. As a user of any designed artifact, such as a live coding language, you will have to accept the design assumptions and decisions and adjust to them. Being able to design your own language liberates you from this. Sema aims to provide a workflow that empowers you to achieve this. It enables you to design your own live coding language according to your own needs, context, taste, and overall aesthetics. Before starting with the specifics of the language design workflow, it would be good to have a few words about why language design and implementation is important and why you may want to know more about it. Language design and implementation taps into many aspects of computers and computer science. When you hear about zeros and ones and machine code, which is a language that's very foreign and naturally hard for humans to use. So, what's been happening in the last 70 years or so in computer science is an effort of abstraction towards human language, where languages were created with more and more abstraction levels, starting from machine code to assembly, which was abstracted to imperative languages like Fortran, which was the first high-level language created by John Backus, which we'll hear about in the tutorials, and C, and even higher level even higher abstract languages such as object-oriented languages like Smalltalk or Java, or even higher abstraction languages such as functional languages like Haskell and Lisp, and logic languages such as Prolog. So these are mostly general purpose languages. And then we have domain-specific languages, which are very abstract and specific to a domain. They are designed to be optimal to a certain domain and to have the domain abstractions. For instance, live coding languages for music. So Sema provides an environment which is optimal for the design of live coding languages. So all of this to show you that it might be of interest to you if you want to understand better languages that help you to be more creative with sound and music, or to apply creative computing, or to have a fun-based approach to computer science concepts, and to understand how things work under the hood.